Right here, guys, we're going to take a look at your cumulative assessment review. Make sure you take good notes. And honestly, I just want to see you do your best, the very best, okay? Let's get started. So, on this first part right here, it says, when doing the derivative of the law of sine, we use the non-right triangle. All right. What must you do to get right triangles? Well, if I got a triangle right here and I want to make right triangles, I simply cut it. All right, I cut it. And there's the height. So now I have two right triangles. All right. So again, man, you draw a height. You draw a height to create two right triangles. All right. Now, number two right here says, since the law of sines uses two sine ratios, how do you make the two trig function equations into one equation? One value must be in both equations. So yeah, here's what you got to do, right? To do this, we're going to say, let's make this A, and we'll make this C, this is B. But to make this, we'll say sine of A. All right, sine of A equals sine of C. I'm going to show you why in a second, because sine of A is opposite over hypotenuse AB, and sine of C is opposite over hypotenuse, and they're equal. Sine of A is equal to sine of C. All right. But sine of A and sine of C will both use the same height. So now we show the proof of this whole thing. All right. And the proof derives directly from what we've been saying today. All right. If I say that sine of A, here actually, let me change the thickness of this pen. If I say sine of A equals h, which is the height. Remember we said sine of A is h over side AB. By the way, let me relabel this real quick. I said this is side AB. I'm going to call this, this is angle C. I'm going to call this side C. And see how this over here is side A. It's side BC, but it's opposite of angle A. So we're going to call that little a. Now, when I do the proof, sine of A equals h over side C. All right. And we're going to say that sine of C equals h opposite over A. Like that. Now, we can isolate h on both of these. When I isolate h over here, if I multiply by C on both sides, all right, h is now by itself. So I have C sine of A equals h. And over here, I can isolate h by multiplying my A on both sides. So h equals A sine of C. So you see how both of those equal h now? Okay, the same h. Well, since they equal h, I can set these equal to each other. I can say C sine of A equals A sine of C. And now, if you think about the law of sine rules that we've used, equals. Hold on, let me rewrite that. That's all right. So now, when you look at this, what we can do is we can now isolate sine of A with A and sine of C with C. All right, so I'm going to start by dividing by sine of A on both sides. Right? So you see I have C equals A sine of C over sine of A. And then right here, I want to now divide by sine of C on both sides. All right, I want to get rid of sine of C over here on the left. So I'm going to divide it out over here. I'm going to put it over here, sine of C. So I'm left with C over sine of C, which equals A over sine of A. And if you remember, that's your law of cosine rule. Side C over sine of C equals side A over over sine of angle A. That's the law of cosine. So this is how you derive the law of sine, which is right there. All right, the only one we didn't include was, you know how it equals B, side B over sine of B. All right, so, but that's how you derive sine. All right, moving along. So right here it says a tourist attraction currently has a zip line attached from a base to a platform that's 150 meters away. So I like to draw as I read. All right, so there's a platform, there's a base, and they are 150 meters away. All right, it says the owner wants to make a second zip line platform across the canyon, attaching from the base and the first platform. So they want to make a platform too, all right, that connects this base to that platform and this other platform to that platform, all right? And now it says the angle formed from the base to the two angles is 41. So here's the base. The angle formed to the two angles is 41. So that's 41. And then it says the angle from the first platform is 69. Or the angle at the first platform is 69. All right. So it says what are the lengths of the two zip lines? So this is P1. We'll call this side A right here. And we'll call the base, we'll call this side B. So they want to know how long this zip line is, how long this zip line is. So first, what I'm going to do is, so I can use the law of sines, I want to find this third angle right here. So 69 and 41, that's 100, 110. So 180 minus 110 is 70 degrees. So this angle right here is 70. So now I have a complete ratio right here. All right, I can use law of sines. I have 150 over sine of 70 equals, and I'll find this side first. So I'll go A over sine of 69. Well, we're going to isolate A. So 150 sine of 69 divided by sine of 70 will give me A. All right, and when I punch that into my calculator, I get A is 149 meters. All right, so this is 149 meters. And then I do the same exact thing for B. I'm going to do 150 over sine of 70 equals B over sine of 41. Now, isolate B. And when I punch that into my calculator, 150 sine of 41 divided by sine of 70, I get 104.7. 104.7. So this is 104.7. All right. Now, allergies. Number 5 here. A freestanding art project requires a triangle support piece for stability. Two sides of the triangle must measure 25 and 15. So that one they gave to us. We got a triangle. Matter of fact, here, I got a triangle. Two sides must be 25 and 15. Cool. Done. It says the angle opposite of 25 is 48, so that's 48. And the angle, it says what is the measure of the third angle? Okay, cool. So we got to find the measure of the third angle. So what I'm going to do is use law of sine for this one. And I'm going to find this angle right here. I'm going to start by finding this one. So I could do 25 over sine 48 equals 15 over sine of angle. Here, let's do this. A, B, C. So angle A. So we're gonna end up using sine inverse right here. But anyway, we isolate sine of A. We have sine of A equals 15. You got cross multiply, so 15 sine of 48. And then we'll end up dividing by 25. All right. And then we'll have to inverse this because we can't take the side of A. So we got to take the side inverse of this side. So you end up with A equal to the sine inverse of 15 sine of 48 all over 25. And when you punch that in, you get 26 points. Nope, just 26 degrees. We're around 7 degrees, so 26 degrees. All right. It looks like 260. I don't want that big. 26 degrees. Now, we use these two right here. If we add them up and subtract from 180, right here, this is going to give me 44. 48. Sorry, that's 48. That looks terrible. 48, 68, 74. So 180 minus 74 is going to give us 106. 106. So we now know that this angle B right here is 106 degrees. Now I'm going to use that to find this missing side B down here. So I'm going to go same ratio right here, 25 over sine of 48 equals side B over sine of 106. Let me do this because this looks like a 6. B, letter B. All right. So now isolate B. So you have 25 sine of 106. Ooh, I'll put 166. (106) divided by sine of 48 equals B. And then when we solve that right there in our calculator, we're going to get B is 32.2 feet. All right, so B equals 32.2 feet. All right, so there's our third side. All right, tell me how many triangles are possible given the following information. First of all, make sure you know the difference between obtuse and acute angles. All right, obtuse is an angle greater than 90 degrees. Acute is an angle less than 90 degrees. All right, so let's get started. First of all, this angle is bigger than 90 degrees, so this is obtuse. All right, so now since we know that that's obtuse, we now look at the opposite. Oh, by the way, guys, if I have angle A and side A, these two are opposite. So this is the opposite side, and this is the adjacent side, okay? So now we have the opposite side, in this case, is greater than the adjacent side, all right? So when you have an obtuse angle and the opposite side is greater than the adjacent side, this is one triangle. That won't fail, all right? We're not solving right now. It's just saying, hey, there's one triangle, all right? Now, over here, number seven, again, we have an obtuse. We have an obtuse angle. Now, The opposite side is 14. This is opposite. And this is adjacent. But this time, I want you to see the difference. This time, the opposite leg is less than the adjacent leg. 14 is smaller than 15, so less than, right? So what that tells us is there is no triangle. All right. Again, when the obtuse angle, you have obtuse angle given, and the opposite side is less than the adjacent side, there's no triangle. All right. Now, let's jump to number 8. Number 8. Well, here let's. All these are acute angles. So, okay, cool. So number 8, we see we have an acute angle, and it's acute because it's less than 90 degrees. And then we have side A, opposite, is less than side B, the adjacent leg, right? Opposite is less than adjacent. Well, since this is acute and opposite is less than adjacent, it's not like over here where it's obtuse and opposite is less than adjacent. It's acute and opposite is less than adjacent. That means there is 0 or 2 triangles. And we need to figure out which one it is. So what we're going to do is we're going to check the height. Now height equals adjacent times sine of the given angle A. So height equals 38 sine of 30. And when we punch that in, we get 19. So, you know what happens right here? See how the height is 19 and A is 19? What that means is the height, man, I can't draw. The height 19 and the opposite side is the same thing. So this is actually a rare case right here. This is actually a right triangle. A right triangle. So it's only one triangle. And it happens to be a right triangle right here. Because again, the height and the opposite leg are the same. So that means they're the same leg. The opposite leg is the height. Alright, so it's a right triangle. Over here, let's see. A is smaller than 90, so it's acute. It's an acute angle. Now again, A, the opposite side, is less than the adjacent side. So that tells me that there's 0 or 2 triangles, and I got to check the height again. So just like the last problem, H equals adjacent sine of the given angle. And in this case, the height is going to be 29.1. Alright, now we see that 29.1 is less than the opposite leg, right? It's just less than the opposite leg. And we know the opposite leg is less than the adjacent leg, right? So that means there's 2 triangles right here. 2 triangles, alright? 2 triangles. When the H is less than the opposite leg, there's 2 triangles. For 11, since I'm already here, again, this is acute. Less than 90. The opposite leg is less than the adjacent leg, right? 5 is less than 6. So that could be 2, because it's the same condition. It could be 2 or no triangles. So I check the height again. So we're going to go 6 sine of 63. And when we do that, we get 5.346. So see how this height is greater than the opposite side, greater than A? Well, when this is greater than A, that tells us right there that this is no triangle. Alright, right here we saw that the height was less than A. So that told us 2 triangles. But this time the height is greater than A, so no triangle. Alright. And now one more. Let's look at we need, 10. 10 is acute. A is opposite is less than adjacent. So with that being said, what we can do is we can, well, we got 0 or 1 triangle, sorry. 0 or 2 triangles, right? So we need to check the height again. Right? 9 sine 26. And when we do that, we get 5.945. No, it's 3 point. Sorry. 3.945. So see how this is less than A? That means there's 2 triangles. All right, this is the same conditions as number 9. So that number 9 gave us 2 triangles. All right, let's keep rolling. Right here it says, using the area formula, solve the following. So, remember, area equals 1/2 base times height. So when you're dealing with a triangle, area equals 1/2. Well, let's look at our triangle real quick. Well, 1/2 base times height, or 1/2 AB times AC, sine of the given angle A. All right, the inclusive angle. So in this triangle ABC, we have angle A, is 61. AB is 12. AC is 15. So this is an inclusive angle, side angle side. So we have 1/2 times 12 times 15 sine of 61. And when we punch that in, we get area equals 78.7 inches. 78.7 inches squared. All right, right here in the isosceles triangle, there are 2 legs that are 14 inches. So that just tells us 14, 14. All right. And the included angle, the angle in between those 2 legs is 62. So side angle side again. So find the area. Well, area equals 1/2 14 times 14 sine of 62. Side angle side, guys. And in doing so, area equals 86.5 inches squared. Now for 14, let's see here. If you were to derive the formula for the area of the triangle using the sine function, what would be the equation used to substitute for the height of the triangle? Well, remember, area equals 1/2 base times height. And so if I had that triangle, I'm gonna use the same triangle we used earlier. Wrong shape. Triangle. There we go. If I use that triangle where I had cut it and found the height. All right, so now I have 2 right triangles. All right, let me label this thing up A, B, C, or this is side C and this is side A, and this is now the height H. All right, I'll use sine of A. So sine of A equals opposite, which is H, over hypotenuse, which is C. See, opposite over hypotenuse for the right triangle. Okay. So when I isolate H, right, because I want to find the height, right, I need to identify what this is. All right. Oh, and by the way, the base is the base. Base is B. Well, we get h right here is going to be, let's isolate h, so multiply by c on both sides. So h equals c sine of a. All right, c sine of a. So when you actually make the equation, you have a equals 1/2 the base, whatever the base is, times the height. Well, what do we know the height to be? C sine of a. Now right here, more area. It says find the area of the triangle if the two sides are 15 and 28 with an included angle of 29. So 15, 28, 29. 1/2, 15, 28, sine of angle 29. And when we punch that in, we get the area equals 101.8 centimeters. Centimeters squared, kilocentimeters. All right, find the area of the triangle shown. All right, so for this one, I need to include an angle. This angle is not included. I have 37. I would need to find angle C, or I would need, for this one, I would need side C and side B for that to be included. So let's do this. First, let's find angle C. I can find angle C right now because 83 and 71, if I add those up, I get 154, and 180 minus 154 is going to be 26. So this is 26 degrees. So now I can use the law of sines to find a missing angle. I mean a missing side. So I'm going to use law of sines right here. So I'm going to say 37 over sine of 83 equals, let's find this side right here. Side B. So B over sine of 71. Anyway, cross multiply. Divided by sine of 83, and that equals B. There's B right there. So B equals, and this is going to give me 37, nope, sorry, 35.25. So now I have side angle side. All right, I know you did the video with me. I think I found C first and then did that. Side angle side, but we should get the same thing. So in this case, area equals, or not, we are going to get the same thing. Area equals 1/2 times 37 times 35.25 sine of 26. So let me punch this in the calculator right here. 35.25 sine of 26, and that gives us 285.87. All right. Area equals 285.87. All right, let's hypothetically look and show you if I would have found this angle right here, this side right here, side C. All right, so if I use law of sines real quick, and I just want to show you. So if I'm at 37 over sine of 83 equals side C over sine of 26, you see, right, 37 sine of 26 divided by sine of 83, and that'll give me 16, C would be 16.34. So we did the same thing with 71. If we found the area using this inclusive angle right here, and these two sides, you'd have 1/2 37 times 16.34 sine of 71. And when I punch that in the calculator, I get 0.5 times 37 times 16.34 times 71. I get 285.82. So it's the same thing. All right. All right. We really didn't need two examples there, but I just wanted to show you. Yo, so this video hit 30 minutes. I'm actually stopped there. This is 1 through 16. I'm going to stop this video here, and then I'll make another video starting at 17.